For the most part, the timeline between signing a contract and launching payloads into space is a very thorough process that takes years of time. This usually only increases as the payload gets bigger and the destination more distant. Companies and agencies often are faced with the extremely important task of picking the best launch vehicle and launch provider for their valuable payload. Yesterday, SpaceX's Falcon 9 lifted off with the European Space Agency's Euclid Payload on board. While exciting, what's most interesting is the fact that the agency and company came to an agreement not years ago, but earlier this year in January. That would mean that in only around 5 months, SpaceX went from contract signing to ready for the launch of a next-generation space telescope. This is a big deal, and when combined with the low prices offered by the Falcon 9, makes SpaceX extremely appealing to those in need of a launch provider. Here I'll go more in depth into this fast turnaround time, the complexities of this launch, what to expect in the coming years, and more. Normally, launch contracts for dedicated payloads are signed and coordinated years prior, and there's a reason. Whether it's payload integration, vehicle testing, export policies, general delays, etc., the process is by no means simple. Despite this, ESA needed a rocket and needed one fast. Back in 2020, the agency was quoted saying, "The Euclid mission will utilize either a Soyuz or an Ariane 62 launch vehicle with a launch timeframe starting in mid-2022. Launching this mission aboard an Ariane 62 or Soyuz is further proof of Arianespace's ability to offer independent access to space for Europe's ambitions," they said. While the last sentence didn't age very well, eventually, the agency decided on the Soyuz and was preparing for that rocket. Unfortunately, conflict arose and the ESA needed a new option. By then, Euclid was already complete and well into its final round of pre-launch testing when ESA had to search for a new launch vehicle. Ideally, the backup option, a European Ariane 6 rocket, would be the next best choice. This, however, was not and still isn't an option as the launch vehicle has continued to run into delays. Out of options, European officials began talking with SpaceX about 1 year ago, and the switch to a foreign rocket was approved, not something ESA is fond of. This being said, if they hadn't made the switch, Euclid would likely remain grounded until at least 2025. Mike Healy, head of science projects at ESA, talked about SpaceX and was quoted saying, "We owe them a huge thanks. Without them, our satellite would be sitting on the ground for 2 years." He also gave more insight into the ambitious timeline between the two. The first discussions with SpaceX were in May of 2022, he said, followed by feasibility studies and testing to ensure Euclid was compatible with the Falcon 9. While ESA announced in October its intent to launch Euclid in another mission, the agency didn't sign a final contract with SpaceX until the end of January. "We had to squash what we normally do in 3 years into 5 months, he said, regarding the switch to the Falcon 9. That required dealing with a number of challenges ranging from technical issues of integrating the spacecraft with the rocket to dealing with U.S. export control policies. Not to mention, due to the future operations and the general goal of the Euclid payload, special requests were made." Stephen Clark at Ars Technica reported that SpaceX charged ESA about $70 million to launch Euclid. That price is about $5 million above the standard commercial list price for a dedicated Falcon 9 launch, covering extra costs for SpaceX to meet very specific cleanliness requirements for the Euclid telescope. They noted that a grain of dust or a piece of hair on the telescope's optics could ruin this mission. With this in mind, SpaceX also provided a brand new payload fairing for the Euclid mission to reduce the risk of any contaminants falling onto the telescope. Normally, launches employ a payload shroud reused from previous missions. It's also important to point out that this payload is headed to the L2 point, similar to the James Webb Space Telescope. With all things considered, SpaceX not only prepared the Falcon 9 for a big mission in around 5 months, but did so with special circumstances throughout the process. ESA's Euclid spacecraft lifted off from Cape Canaveral Space Force Station in Florida at 1712 CEST on July 1st. The successful launch marks the beginning of an ambitious mission to uncover the nature of 2 mysterious components of our universe, dark matter and dark energy, and to help us answer the fundamental question, what is our universe made of? Following launch and separation from the rocket, ESA's European Space Operations Center in Germany confirmed acquisition of signal from Euclid at 1757 CEST. The Falcon 9 booster completed a landing on a short follow gravitas with great views from SpaceX. Not long after, the company tweeted, "Deployment of ESA's Euclid confirmed," which included a short video of the payload separating from the upper stage. The successful launch of Euclid marks the beginning of a new scientific endeavor to help us answer one of the most compelling questions of modern science, said the ESA Director General. He continued by saying, "Euclid has been made possible by ESA's leadership, the effort and expertise of hundreds of European industrial and scientific institutions, and through collaboration with international partners. The quest to answer fundamental questions about our cosmos is what makes us human, and often it is what drives the progress of science and the development of powerful, far-reaching new technologies. ESA is committed to expanding Europe's ambitions and successes in space for future generations, he said. The telescope will observe billions of galaxies up to 10 billion light-years to create the largest, most accurate 3D map of the universe, with the third dimension representing time itself. This detailed chart of the shape, position, and movement of galaxies will reveal how matter is distributed across immense distances and how the expansion of the universe has evolved over cosmic history, enabling astronomers to infer the properties of dark energy and dark matter. Today we celebrate the successful launch of a groundbreaking mission that places Europe at the forefront of cosmological studies, said ESA's Director of Science. If we want to understand the universe we live in, we need to uncover the nature of dark matter and dark energy and understand the role that it played in shaping our cosmos. To address these fundamental questions, Euclid will deliver the most detailed map of the extragalactic sky. This wealth of data will also enable the scientific community to investigate many other aspects of astronomy for many years to come. To achieve its ambitious scientific goal, Euclid is equipped with a 1.2-meter reflecting telescope that feeds the two innovative scientific instruments, VIS, which takes sharp images of galaxies over a large fraction of the sky, and NISP, which can analyze galaxies' infrared light by wavelength to accurately establish their distance. To cope with the vast amounts of data Euclid will acquire, ESA's S-Track network of deep space antennas has been upgraded. The data will be analyzed by a group of more than 2,000 scientists from more than 300 institutes across Europe, the US, Canada, and Japan. In the next 4 weeks, Euclid will travel towards Sun-Earth Lagrange Point 2, an equilibrium point of the Sun-Earth system located 1.5 million kilometers from Earth, about 4 times the Earth-Moon distance, in the direction opposite from the Sun. There, Euclid will be maneuvered into orbit around this point, and mission controllers will start the activities to verify all the functions of the spacecraft, check out the telescope, and finally turn on the scientific instruments. Scientists and engineers will then be engaged in an intense 2-month phase of testing and calibrating Euclid's scientific instruments and preparing for routine observations. Over 6 years, Euclid will survey 1/3 of the sky with unprecedented accuracy and sensitivity. As the mission progresses, Euclid's treasure trove of data will be released with a yearly cadence and will be accessible to the global scientific community via the Science Archive hosted at ESA's European Space Astronomy Center in Spain. While the ESA would have loved to launch the telescope on their own rocket, until it's ready, options such as SpaceX will be available and capable of fast turnaround times as demonstrated here. SpaceX and the ESA just launched a next-generation space telescope around 5 months after signing the contract. This is an extremely impressive feat from both the agency and company, and highlights the speed at which missions can be completed when necessary. We will have to wait and see how it progresses and the impact it has on the space industry. Thank you very much for watching.